My name is Doug Morby. I'm the Manager of Utilities at Narromine Shire Council. The management of water treatment plants, whether they're large or small, and this plant at Tomingley is on the smaller side, all carries the same level of responsibility. The key responsibility is to ensure that we reach the targets set for us by the health regulation. The health regulation prescribes a series of targets that are very important in relation to things such as E. coli, coliforms, and some of the other microorganisms and metals that you can find in all different types of water. The Tomingley plant in particular, being a new technology and a new plant, has meant that we've needed to do a fair bit of overwatch and a fair bit of what we call process proving the technology, proving the results with daily testing for microbiological results and for metals contamination. It's a pretty large responsibility when you start providing drinking water to a community, no matter what size plant you're running or operating. Tomingley found us with a rather unique and unusual problem in that there is no natural source water supply to the village. The local creek running through the village is slightly polluted with insecticides and was therefore deemed not of a decent enough quality to be used. There is no groundwater naturally occurring in the Tomingley area, and we were rather fortunate in that a bore belonging to the Alkane Tomingley gold mine had a pipeline that ran right past our plant location. That pipeline actually comes from here in Narromine, where they pump raw water to their mining operation. Council was able to negotiate with the mine to obtain a regular but spasmodic supply of water for the plant to operate from. That water amounts to a total of 11 megalitres a year, which can be delivered whenever they have excess water available, but not necessarily every day. Therefore, we have to store it in an above ground dam, which is 30 megalitres in size. That water brought with it the normal problems around groundwater from the Macquarie alluvium, which was that of iron and manganese, and some minor levels of chloride in the water as well. Added to that was the compounding issue of having it stored in open air storage, which means that it becomes subject to microbiological contamination from flora and fauna and potential ingress of vectors into the system. This made the choice of membrane technology the first choice that we went to. The conventional polymeric membranes were considered in the first instance to be what we were going to go with, but the advent of the ceramic membrane onto the scene certainly changed the game from where we were concerned, in that it delivered all requirements and reduced the potential risks to the system and delivered the system at a much lower long-term maintenance cost than would have occurred with polymeric style membranes. The membrane technology solved all our problems in relation to being able to combine the removal of heavy metals, iron, manganese, potentially some chloride, and deal with the microbiological hazards of E. coli, Cryptosporidium and Giardia in the one pass, rather than having to have multiple systems of membranes, filtration and large amounts of chemical dosing to bring this about. The membrane technology has meant that for a substantially lower cost than conventional filtration technologies, we have been able to provide Tomingley with water that meets not only the Australian Drinking Water Guidelines, but the latest in microbial health-based targets for water supply. It enables us to reach the parameters set within the regulations without having to rely on multiple pass systems and multiple chemical dosing systems to obtain that result. The thing that attracted me most to silicon carbide flat sheet membranes was the robust nature of the membrane. The fact that it was nowhere near as fragile, nowhere near as subject to damage from accidental overdosing of flocculants, was more robust and far easier to clean, to manage and to replace should there be a problem. The whole concept of the flat sheet membrane was very attractive from a maintenance perspective and a long-term viability perspective. The fact that you can actually clean them with a pressure washer, which is something you just cannot do with any other form of membrane technology, made them enormously attractive when we have limited maintenance services available and a limited ability to have a full-time operator on the site. This plant operates pretty much as a remote plant. It's all controlled by remote SCADA technology, and it's observed via a series of video cameras in its operation. Therefore, minimal intervention by operator is what we were looking for, and the very, very robust nature of the flat plate membrane made that possible. I see the best fit for this type of membrane technology in many different aspects of water treatment, particularly in areas where you're dealing with mixed problems such as those we've had to deal with. The presence of contaminants and metals, the presence of environmental and microbiological risks mean that this membrane is readily adaptable, very easy to optimise in relation to the type of flocculants and that you use with it, very easy to optimise in relation to the precipitation of iron and manganese, and it is a very, very, again, robust, and I keep using that word, technology in relation to what you can do with it. Particularly where you are trying to achieve reductions in turbidity, which is your primary indicator for microbiological contamination. We are bringing turbidities from as high as 80 NTU down to less than 0.1 NTU via this system of membranes without a real lot of difficulty. That to me is a really big step for the future of water treatment and filtration. I am aware that technology has been used overseas for pre-RO of seawater. It's used in food manufacture and technology. It has many different applications which I think will only increase as time goes by. The ability to add an absorbent to the outer surface of the membrane, particularly in relation to PFAS and microplastics removal, I think is going to be a really big attraction for many of the people who adopt this technology. The advice I would give to any local water utility in regional Australia that's looking for a solution that ticks all the boxes in relation to microbiological compliance as well as the removal of contaminants is to really pay close consideration to the use of these membranes. We are at a tipping point in our water cycle in this country where we are having to more and more use brackish or contaminated waters to meet our supply needs for our communities. Anything that allows us to do that with a minimum amount of intervention and a minimum amount of excessive chemical dosing, in my mind, is a plus and a benefit to all. These membranes, I believe, can be a game changer for both small and large utilities and for both small and large systems. They hold many of the answers to many of the problems that we've looked for many years. The key advantage I see of ceramic membranes over conventional polymeric membranes is just the robust nature of the membrane surface itself. You can subject it to quite a bit more punishment than what you can a polymeric membrane. Where you're working with in areas where you've got lower levels of operator intervention and lower levels of on-site monitoring, the conventional polymeric membrane can often be a bit of a hazard from the point of view that they're very easily destroyed by mismanagement. Whilst they deliver a superb product, they just don't have the robust and minimal maintenance capabilities that the ceramic membrane does. To me, the primary advantage has got to be the simplicity of the system itself, the structure of the membrane, how it actually functions, and the fact that it is so tough and so easily brought back after it has been basically blocked by whatever your filtrate is that you're putting through it. The recovery is quite amazing. And particularly the way Infinite have constructed this system for us. Whilst it may, when you look at it, appear complex, it is a very, very simple system, relying on a couple of very simple principles of filtration. And that, to my mind, is probably the big plus in this technology. The reason I chose Infinite Water was the confidence that they exhibited, the fact that they had access to the technology. They had people on board who had actually worked with it overseas, so they had experience in the technology. And in fact, they were the only company that I could find in Australia with any experience in this type of membrane technology. They also have and continue to stand totally behind this project. They have invested a lot of time in the project with us to make it a success and have stood by us every inch of the way, providing support in the design stage, support in the construction stage, commissioning. I can't fault the work that they've done, so very, very happy with what Infinite has delivered so far.